Hello, this is Miss Moore, and today during chemistry we're going to discuss calculating pH. Today's essential question: what is pH and how is it measured? For today's lecture, you're going to need your calculators handy. And another quick review on acids and bases. Acids are hydrogen ion donors, meaning they release hydrogen ions in solution. And when they release hydrogen ions, they hook up with a water and produce hydronium. So you can think of acids also as hydronium ion producers. Okay, bases are hydrogen ion acceptors, meaning they gain hydrogen ions in solution. What is pH? pH is the measure of the amount of H+ ions in solution. It can also be a measure of the amount of H3O+ ions in solutions. Because again, when you put an acid in water, the acid releases an H, which hooks up with an H2O to make H3O. So for this discussion, H+ and H3+, the amounts are interchangeable. Okay. So the greater the amount of H+ ions or H3O+ ions in solution, the more acidic the solution. A basic solutions would have lower concentrations of H+ or H3O+ ions in solution. Okay, and let's do a really quick review on the pH scale. Remember that pH scale ranges from 0 to 14, and that a neutral solution, which means it's not acidic or basic, would have a pH of 7. Acidic solutions have pH of less than 7, so 0 to 6 or something. And the smaller the number, the more acidic. So something with a pH of 1 is very acidic, where something with a pH of 6 is not so acidic. Basic solutions have a pH of greater than 7. The larger the number, the more basic. So something with a pH of 14 is very, very basic. So again, neutral solutions have a pH of 7. And as you move away from 7, if you move lower than 7, you get acidic solutions and they become more and more acidic the farther you get from 7. And if you move above 7, you get basic solutions, and the farther you get from 7, the more basic. Okay, calculating the H+ or H3O concentration. When an acid is added to water, an H+ ion is released, creating a hydronium or H3O ion. When a base is added to water, an H+ ion is taken from water, creating hydroxide or OH1-. The concentrations of H3O and OH in any solution is always 1 × 10 to the negative 14th, always. So that leads us to this formula here. The concentration, remember the brackets here? Brackets mean concentration of something, okay? So the concentration of H3O times the concentration of OH in any solution equals 1 × 10 to the negative 14th. Which means if you know the concentration of either H3O or OH, you can calculate the concentration of the other one. So now let's try that. Okay, so for practice, if the concentration of H3O in blood, so H3O is 6.5 × 10 to the negative 9, we want to know the concentration of OH. Well, we've got that formula, concentration of H3O, or H+, either way, times the concentration of OH equals 1 × 10 to the negative 14th. Be best if I knew how to write, negative 14th. All right, so now we just plug in what we know. We know the concentration of H3O is 6.54 × 10 to the negative 9th. We're trying to find out the concentration of OH, And those multiplied together always equal 1 times 10 to the negative 14th. So to solve for OH, which is our x, we'll divide both sides by 6.54 times 10 to the negative 9th. And that gives us an OH concentration of 1.52905, etc., times 10 to the negative 6th. Right, and if we go back and try to figure out our sig figs, because this is a given, because this is a constant, it's always true, we'll ignore that number. We'll just look at our given here. And that has 3 sig figs, so we'll keep these 3. So our final answer will be 1.53 times 10 to the negative 6th. Not too bad. Now let's talk about calculating pH. pH is the negative logarithm of the hydronium ion concentration. And the formula for pH is pH equals negative log of the concentration of H plus, or pH equals the negative log concentration H3O plus. Remember, in this case, H plus and H3O plus are interchangeable because an acid loses an H when it's put in water, and that H goes and hooks up with a water molecule to make H3O. All right, POH is the negative logarithm of the hydroxide ion concentration. Formula, POH equals negative log of OH. Okay, let's practice using the log button on the calculators before we get to a real problem. So just real quickly, let's say we had something with a concentration, an H3O concentration of 3.00 times 10 to the negative 2. So how do you put this in your calculator? Unfortunately, it's going to depend on your calculator. For some of you, you will put it in your calculator exactly like the equation. pH equals, so you would put in a negative, use your negative button, and then look for your log button, which for a few of you will be a shift key, but for most of you not. And then you would put in 3.00 and your EXP or EE button, negative 2 equals. Okay? And that gave me an answer of 1.52287 and so forth. Now, if you did not get that answer, or if you got something like syntax error, we're going to have to try putting it in your calculator a little bit differently. So if you did not get the answer 1.52287, or if you got syntax error or something, putting things in your calculator this way, then you're going to need to put it in your calculator completely backwards. You'll start with putting in the concentration of the H or the H3O. Then you'll put in the log button, and then you'll put in the negative sign. So when you put yours in your calculator, it would look something like this. 3.00, your EXP or EE button. Then you would put in 2 as our exponent and then a negative. Then your log button and then your negative. And then hopefully you'll get the answer 1.52287 and so forth and so forth and so forth. So hopefully one of those two ways got you to be able to use your log button. I'm going to suspect that for most of you, this is what you'll use. Now let's try a real problem. Okay, so here's our sample problem. You have a solution with an H3O concentration of 4.56 times 10 to the negative 9th. what are the concentrations of OH, pH, or of OH, and what are the pH and pOH. What I normally do is write a data table. So I'll start with the concentration of H3O. And then I'll have the concentration of OH. And then I'll have the pH, pOH, and the last column, is this thing an acid, a base, or neutral? And from there, let's plug in what we know. We know that our H3O is 4.56 times 10 to the negative 9th. So what formula do we have that has H3O in it that can give us either OH, pH, pOH, or whether it's an acid, base, or neutral? How about H3O times OH gives us 1 times 10 to the negative 14th. We were given H3O. We'll solve for OH, so we'll get some information. So we'll use concentration of H3O times concentration of OH gives us 1 times 10 to the negative 14th. We know concentration of H3O, which is 4.56 times 10 to the negative 9th. We want to determine the concentration of OH. So now let's solve for OH by dividing 1 times 10 to the negative 14th by 4.56 times 10 to the negative 9th. And that gave me 2.19 sig figs times 10 to the negative 6. 2.19 times 10 to the negative 6th. So now we know concentration of H3O, concentration of OH. We still need to solve for pH and pOH. So do we have any equations that have H3O or OH in it that allow us to solve for pH or pOH? Well, how about this guy here? pH equals negative log concentration of H plus, or concentration of H3O. So pH equals negative log concentration of H3O. So pH equals negative log of 4.56 times 10 to the negative 9th, which gives us 8.34 because of sig figs. So our pH is 8.34. Now let's see if we can solve for pOH. To calculate pOH, we can use pOH equals negative log concentration OH, and we do have that information. So pH, nope, try that again. pOH equals negative log concentration of OH. So pOH equals negative log of 2.19 times 10 to the negative 6th, which gives us 5.66, accounting for sig figs. Okay, the last thing we need to figure out is if our solution is acid, base, or neutral. How do we do that? We're going to be using the pH scale, pH. Something with a pH of 7 is neutral. Acidic is going to be something less than 7. Basic is going to be something greater than 7. Remember, though, we're talking about pH. So let's look back at our problem. And our pH is 8.34, which is greater than 7, which means that our solution is basic. Okay, that's really all there is to doing pH calculations. For each problem, you'll be given some information, H3O or the OH for today, and you can calculate the rest. All right, quick review on calculating pH and POH. As you know, you can calculate pH or POH if you know the concentration of H3O or H+, or the concentration of OH using these equations here, which you're already familiar with. So you can also calculate the concentration of H3O or the concentration of H+, remember those are interchangeable terms, or the concentration of OH from the pH or the POH, which means if we know pH or POH, we can use a new formula to calculate H3O or OH. So let's go over the formulas real quick and then we'll talk about what they mean and how to use them. All right, so to calculate the hydronium concentration, or again, the H+ concentration, you're going to use this formula here. The concentration of H3O equals 10 to the x of the negative pH. Okay, 10 to the x is what we call the anti-log. Okay? And to calculate the hydroxide ion concentration, you're going to use the formula hydroxide concentration equals 10 to the x or anti-log of negative POH. Okay, let's talk for a minute about this 10 to the x. Where would you find this on your calculator? All right, unfortunately, it's different for different calculators, but let's start with probably the most basic one. Some of you have a designated log button on your calculator. And if you do, right above that, as a shift option, should be 10 to the x. So it's not its own button. Log would be its own button, and then above it should be a 10 to the x. Now, for some of you, on the other hand, you may have some button, I don't know what, and your log button is a shift key. If that's the case, hit shift, then log, then look up above at your screen, and you will probably see two options. Log, and then 10 to the x, or it might be 10 to the caret looking thing. Okay, so what you're going to have to do, it's probably underlined log when you start, so you're going to scroll over to 10 to the x to use the anti-log button. Okay, let's just practice with these buttons real quick, make sure we can all get the same answer. So if I had a pH of 7, and then what would be the H3O concentration? Okay, so for those of you who were able to put your equations, your numbers the same as the equation in the pH formula, you'll be able to do the same here. For those of you who had to go backwards, you're going to have to go backwards. So what you would put in your calculator is your 10 to the x button, except for it's probably not a button, right? It's probably a shift key. Let's do that again. So you have log, but what you're going to hit is your 10 to the x, and then you're going to hit the negative, and then you're going to hit 7. And that should give you your answer. If you're working backwards, if you're a backwards sort of person, you're going to put in 7, then you're going to put in negative, and then you're going to put in your 10 to the x. Okay, so let's try it and see what we get. And I came up with 1 times 10 to the negative 7. So that's how you use your anti-log button. Okay, and here I have a list of all the acid and base equations that we have used so far. If you want to jot them all down, so if you have them one place, feel free. If you've already got them and you're good with them scattered around, that's cool. But one thing I wanted to point out is on the left side of all these are the things you're trying to find out. So these would be your X's. So if you're looking for H3O or OH, you can use, but you know the other one, you can use the top equation if you're trying to find pH, POH, H3O, or OH. Okay, where what you know is the stuff on the right-hand side, except for the top equation, because you have to know one of those. Okay, so it kind of gives you an idea of what equations you can use. All right, so now let's try a quick practice problem. Okay, so for example, you have a solution with a pOH of 10.89. Calculate the concentration of H3O, OH, and pH. Is the solution acidic, basic, or neutral? Okay, and I jotted down our data table. For me, I find it the best way to keep track of what I'm doing. So what they've given us is our pOH, which is 10.89. So now, we know pOH, so let's go back to our list of equations, and the stuff we know is on the right-hand side, and we know pOH, so we can use that equation there. So we'll have the concentration of OH equals the antilog of the negative pOH. So concentration of OH equals the antilog of negative 10.89. So putting in that into our calculators, that gives us 1.288 with sig figs, 4 sig figs, times 10 to the negative 11. And that's our concentration of OH. So we have 1.288 times 10 to the negative 11. Okay? So now we know pOH and OH. So let's see what else we can use. We know pOH, but we've already used this equation to find OH. We don't need to use that one again. Let's see. We know OH. So how about if we use that equation? So we're going to use concentration of H3O times the concentration of OH equals 1 times 10 to the negative 14th. So we don't know H3O. We do know that we have 1.288 times 10 to the negative 11th OH, and we know that equals 1 times 10 to the negative 14th. So now to solve for H3O, we're going to divide both sides by 1.22. 1.288 times 10 to the negative 11th. And that gives us a concentration of H3O of 7.764, 4 sig figs, times 10 to the negative 4. So 7.764 times 10 to the negative 4. Okay, the last thing we need to calculate is pH. So let's see. This is the stuff we need to find out on the left-hand side. So we can use pH equals negative log H3O. So pH equals negative log concentration of H3O. So pH equals negative log of 7.764 times 10 to the negative 4th. And that gives us a pH of 3.110, looking at sig figs. And the very last thing to decide is if it's an acid, a base, or neutral. We look at pH to figure that out, and our pH is 3.110, which is less than 7, which makes this acidic. So that's how you do this. Okay, let's try one more, but this time hit pause, do it on your own, then hit play and see how you did. All right, so this time our given is 3.45. And while we're here, since they gave us the pH, I'm going to go ahead and figure acid, base, and neutral and get that out of the way. And because 3.45 is less than 7, I'm going to say it's an acid. All right, so now what can I figure out knowing the pH? All right, so I know, right side's the stuff I know pH, so I can figure out H3O. So I'll have concentration of H3O equals the antilog of the negative pH, or the antilog of negative 3.45, which gives me an H3O concentration of 3.55 times 10 to the negative 4. 3 sig figs. Okay. So now that I know H3O, let's see. I can figure out concentration of OH. So concentration of H3O times concentration of OH equals 1 times 10 to the negative 14th. So it's going to be 3.55 times 10 to the negative 4th times the concentration of OH, which equals 1 times 10 to the negative 14th. So that gives us an OH concentration of 2.82 times 10 to the negative 11th. So the only thing left we need to find out is pOH. So let's see, to find pOH, I can use a negative log of OH. So pOH equals the negative log of concentration of OH, so equals negative log of 2.82 times 10 to the negative 11th, which gives us a pOH of 10.5. So there you go. You now know how to use 5 different equations, and in conjunction you can figure out the concentrations of H3O, OH, pH, pOH, as well as whether the solution is acid, base, or neutral. Okay? Before I say that's it for today, something I would like you to think about is, can you see a pattern? Start looking at your problems. You're going to love, if you can figure this out, you're going to be very, very happy. So can you see a pattern between H3O and OH and pH and pOH? Just look through your problems and see if you can see a pattern. All right, now that's it for a day. Have a good one.